Hello, everyone. It has obviously been quite a bit of time, and I apologize for that. I have been all over the place, but I wanted to talk about what I have been up to lately, why I've been so insanely busy. And the reason for that is because I have been working on uh, massive changes to my company. As the company is entirely done in Haskell, I figured I might as well talk about some of them because I'm quite excited about them. So we originally were a interview prep company, and we changed to being a more of a learning company, which is actually partially because of how much I've enjoyed doing this channel. Um, and that meant a lot of changes, and there's still a lot more on the way. But I kind of attacked the architecture problem that we had to start with. Um, and so, we're using an Obelisk project, and so I'll just start off with what is an Obelisk project again. So, an Obelisk project is we can kind of, I mean, this is a little bit chaotic here because this is my actual repo that we are talking about. Um, there will be no secrets that we come across, as those are all hidden in different configs, and I will not be opening this magical box of secrets. But we have ultimately we have a front end, a back end, and we have a common directory, and that's kind of the key details of a Obelisk project, or the key structure of an Obelisk project um, is that we have this kind of shared common that allows us to share, for example, our routes between the back end and the front end. So, the front end could say, I want to make a request to this API. Now, what all have we kind of changed? We've done a number of changes. The biggest change being that we have started using uh, WebSockets a lot more. So the reason for that is because I'll just go. I might as well show it at this point. This is the actual application. It's kind of ugly CSS, very ugly CSS. That's work in progress. Um, Unfortunately, just on the back burner, I will admit. But yeah, in order to support a chat application, we needed to have WebSockets so that, for example, if I go and I send a message, um, well, I shouldn't send anyone a message. I shouldn't also open anyone's messages here. But if I send a message, actually, this here, for example, um, I there's a couple things that need to happen. I need to send the request, and then I also need to be notified about any new messages, including my own. And so it's important that if I go and I send this message and I say, um, "Hello, friends," that I get notified about this message, and that is because I am listening to the back end. Um, yeah, and so how I'm ultimately doing that is I'm using another project here called Rhyolite. This is kind of meant to just be like an informal video. Honestly, just for the sake of getting myself to get a move on. Uh, and so I'm using it uh, from here. Let's see, Rhyolite. So Rhyolite is this awesome um, package, which or kind of package set, I will say that blends together with Obelisk, and so it's actually quite easy to these instructions here just show you how you can use it with an Obelisk project. And it's using a thing called Nixthunk, which I won't get into today, but it basically is just a way to build from source. Build from source, for example, an open source project into your application. And so I am literally just building directly from this GitHub. It's really nice because, like, let's say I don't like this commit. I want to go and I want to use a random, I've never seen this before, this EAC on a map, I can do that through Nixthunk. Um, but I'm just kind of plainly using basically the tip of Rhyolite um, in order to facilitate um, WebSockets. And so there's a number of things to that. Um, yeah. So for example, we have actually started doing most of our requests through WebSockets, and we've actually this is kind of part of doing. Um, but I mean, we didn't necessarily need to do this. We could have kept everything as a normal HTTP request, um, but we just refactored everything to kind of using this using a got it or a generalized algebraic data type for the requests. And so we kind of have encoded that, for example, if I want to send a message, and I'm just going to not use the UI or whatever, right? But the UI is going to hook this up for us. I need to know what chat room I'm sending to, right? So I'm going to be sending to general, and I'm going to be sending hello friends. And that tells me everything I need to know on how to use this API. And so I can just kind of use this data type um, very simply to do this. And I won't dig into the code too much. I'm kind of trying to keep this high level and talk about what is it that we've done that is kind of cool. Um, and so that's kind of more basic. We also have this concept of a view, where a view is basically a piece of data that we are going to have on the front end as a result of some queries. So, on the back end, we have complex logic to go and accumulate all this information about a particular message, right? So I I have a view of this message here, and I can see that someone has reacted with a fire emoji. And so I would, for instance, have in this message reactions that, um, Sergio has given a fire emoji. And yeah, that's what I'll have ultimately. And basically, these are kind of set up like routes that we can listen for, right? So whenever I load this page, I am going to ultimately have GHCJS generated JavaScript, which is going to um, be listening for any updates from my server for one of these routes. So if I want to, this would be listening for chat rooms, right? So if I made a new chat room, I'm just gonna. It's a really ugly UI, so bear with me here. But random test. I want to create random test, and I see here that um, I have been notified by the backend about a new channel called random test. And I'm now realizing that I made that public, so everyone might be confused on why I have this. But oh well, I'll delete that at some point. And yeah, and then we have a number of other kind of listeners that we can ultimately just use like a type, right? It's very, very straightforward to do this. I'll show this because this is more interesting here. Let's go source. Let's go front end. I think it's actually under templates, messages. Yes. So let's go VK. No. Personal. Oh, I want to look for. Sorry. It is in front end. chat channel. So for example, this is that one's a little bit more complex. So we have this kind of cool thing, right? This is actually all the code that we need to get our messages at any given time. So, um, the other reason we use Obelisk is it's a very nice way to use reflex, which is ultimately what you're seeing right here, this dynamic T. And I think this is also a very nice explanation of reflex, or a nice demonstration rather, of reflex, is that we are basically um, watching from for updates from the backend for anything from personal messages, for anything from the personal messages channel. If there is any new messages specifically for me, right? So that can be messages that are a DM, messages that are a group chat, messages that are just in a normal channel. And we have all three of those distinctions, but they're just ultimately a message, right? And so we have this direct kind of view into the database about any new messages that have happened. And logically speaking, over time, that value is going to change. So by definition, it's a dynamic value. And so here we have this dynamic value which models that, right? We have this modeling of dynamic T. And watch is going to build that dynamic by saying how it should change as a result of getting new messages from the backend. The contained data that we will have is going to be a potential value of a map of the request interval and a map of the int-end messages. So this is basically just what is the request interval again? The request interval is a way of dealing with pagination, and the int is a way of dealing with that's actually just the ID of the message. And so of course we use that to order the messages, keep them in order, and that ultimately allows us to build something which is going to be a chat room, right? That's going to be a queue of messages that we can go and look at. And so that's really cool. That's kind of why we started to use WebSockets, is we wanted to build a custom chat application for our community. And we have a lot of ideas that we are yet to be accomplished, but because we haven't had time yet. But that's the kind of key reason for using this over Discord, and the fact that we can, learn from, learn from the context of building a chat application in Haskell. So that's really the core of the Rhyolite updates. The second piece is is something that I have built on my own. So I have forked Obelisk. I am on a custom fork of Obelisk. And why did I do that? Well, where am I here? So I can basically do this. This is the entire reason, is that I want to be able to say, I want to have a separate static build. So what is a static build to begin with? That's where we should start. So I have static here, and this is just basically a Nix build I have. This is a bit outdated, but for example, the specific reason it's outdated, and actually this is a good kind of sense of where we're going with this video, is that I have this Markdown generator here. So Markdown generator to allow us to write a blog very easily. And this is originally how we did it. Is we had just a Nix build script, which is basically, if you don't know Nix, you can think of it as a very fancy, formulaic um, Bash script. That's it. Um, but it's a lot more powerful than that, right? Anytime we build variables into a system, there's a lot more power that we can add on to that. But anyways, so we have our variables in this Bash script, but we're ultimately, again, just running a Bash script. And so all we do is we're going to be building, right? This just defines how to build, uh, this kind of static assets. Um, and so here we're saying take the images directory and just copy them over to the target build. Right? This kind of out is a variable that we have to use Nix with. And so we very simple, copy all of the images over. Um, and ultimately, again, do the same with everything else here. Do the same with audio, do the same with favicons, images, CSS, JavaScript, and the videos. Um, yeah, pretty straightforward. And interesting. This is very old. There's actually a lot of this that needs to be cleaned up. But yeah, that is the core of what we are doing with a Obelisk static directory. Now, keep in mind, we don't actually need to do all this. Um, Obelisk, by default, already provides an option between making your static directory a build, like a Nix build, and just making it you know, a normal directory. So let's say I just didn't do any configuration of Obelisk. I didn't say that this is my Nix build for static, um, which you may have seen when I was looking at the, well, I would have had something very similar to this, but a little bit more straightforward. I would have had something like static. I think you literally just say static files equals dot uh, dot static, right? And or some Nix build expression that import static with some arguments, right? You're just basically calling a function, is how it normally looks. Um, and so yeah, again, we don't need to do that. If we had nothing said, we didn't configure Nix at all for our static directory, then we would just basically have a directory that looks like this, right? We would just kind of shift this directory up into source, and then whatever's in static is just good to go. I could have actually, in my update, I've changed it so that I can just directly say, is this a DRV? Yes or no? And that's for more ergonomic reasons as I've expanded on the capability of static files. And we haven't gotten into why have I done this yet. Um, and if we look at the basic static build and what we would use it for, there's no real point um, as for the additions I have done. But how you would use a static directory is as a build tool. So the common issue that could happen is you write a site, you build a site, you put in an image source, right? You put in an image source. Um, this what's a good example? I mean, this here, this is an image, right? If we inspect this, um, we have this image source. It's this massive thing, right? That we'll understand why that is, but it's this massive thing. And so, like, a really annoying, stupid thing is if I just had a typo and I went like this and I said stank, then we have this really ugly looking thing. So we don't want that. And so how do we avoid that? Is through template Haskell. Um, and I believe I might have a video on this. If I don't, I should do a video on this because it's really cool. Um, let's look at this. Let's look for yes. Oh no, that's something else. There we go. So I have this static image statement here. And so what's really cool is, am I building this right now? Let me test this. Well, I can see if I'm currently building it because I'm going to try and make this fail. So I can see um, my code has compiled, and that means that this image actually does exist in the static directory, right? I could go and prove that, um, but I won't for the sake of time. This is a little bit more interesting. If I do this, I see this error. The file images profile image placeholder .svg was not found um, in static assets. Right. This is exactly what we looked at. This is the build. Right. This is the build. Um, and we in the output of our build, we did not find this image. Right. So, for example, that would also be an issue if, in say our build, we never copied over the images directory. We also wouldn't find it. Um, but yeah, we have a build of our static assets that we can do. We can make it very custom. We can do stuff like Markdown, for instance. We can do arbitrarily whatever we want. But at the end of the day, when we are trying to deploy a working application with zero bugs, we want it to be perfect, and so we have this kind of check in place that we haven't just put in an invalid value, right? We have made this kind of flexible state, right? This static assets directory, which is very flexible. We have made it into uh, something that we can't represent an illegal state, right? We need now see that my server is running again because we have a correct file path or a correct reference to a image. So I thought, wow, that's so cool, and it's even cooler if you dig into it. I had a lot of fun digging into it. There's a lot of interesting stuff they do with both Nix and template Haskell to perform the static functionality of Obelisk. Um, and keep in mind, this also it's really cool because this works on mobile as well. Um, this they deploy to mobile, right, iOS and Android, um, and, and yeah, like it's really cool that this static image represents only valid states, right? This must represent a valid image, uh, regardless of so many different things with the build. So I thought, wow, that's so cool. Um, and I didn't think much of it for a while. Then I thought what I was doing something very simple. I wanted to build a landing page, right? I wanted to build a landing page, and yeah, let's just I okay. So I wish I had a image of the old version of this, but I'll basically pull this up right now. You'll see that it's pretty good. Um, we're talking about Ace Talent IO. Um, yes, yeah. Actually, I think I have a way I can demonstrate this. So I'm trying to demonstrate bad, or good and bad. Um, mobile, there's still some things we have to. We're actually just about done. Um, a lot of different things with this deployment. I should say this is all very brand new. Um, but yeah, you can see on desktop we have 100% performance. The reason it's 88 performance, just by the way, is because of image sizing. Um, but yeah, we had to actually do a lot of work to get our Obelisk project to 100% performance on page speed, right? So this is actually I'm pretty happy with myself on this. Like that, it's very fast, and this is also not using a CDN, which is kind of fun. There's I even learned through this that there's actually an issue we have with our server management, which could make this even faster. So most of the time, even on this first contentful paint, is because of a server lag that has just it's basically a factor of just it's a Nix thing is what I'll say for now. But we need to fix that, and it's just more. It's not complicated, but we just want to make sure that we do it and don't blow up anything. Um, and so I let me see. So okay, so this is Ace Talent IO. The landing. This is the core landing page, which we want very optimized SEO for. There's some details here. These are less important to what we're talking about. Um, these are yeah, and I believe this should be bad. This home it should be really bad. I think it'll be quicker to see desktop, so I'm gonna even do that. Mobile is even harder, so let's just do desktop because this still should be bad. Note to self to speed this up in the video. There we go. So we have crappy performance on uh, our actual application. And so I thought like wow, like we have a really like crappy application. And I realized something ultimately is that there's kind of two different cases of web development. One is static site development, and another is like web application development. They sounded like kind of like almost buzzwordy at a point in time. I will admit, as to what is the actual difference. Like how some people call themselves a programmer, some people call themselves a software developer. These are kind of the same thing. Um, maybe some people have different definitions of them, but for ultimate purposes, they're kind of roughly the same thing. And I thought the same here, that these are just kind of the same thing. Like there's not really a difference. And part of the challenge here is that um, there's also it's worth noting that GHCJS is a very brand new system, right? The ability to compile Haskell to JavaScript is a brand new system, and so I wasn't sure why this was so bad. And the reason why is because ultimately we have this massive transfer size, right? This GHC all JS. This is compiled JavaScript from Haskell. And look, I'm not even scratching the surface. This is everything that we are sending with an application. Is there ways to optimize it? Yes. Will they come in? Yes. But I kind of thought, wow, like GHCJS sucks. You know, I cheat like that's what I thought for a little while, and I realized that actually no, well, there's room for improvement, but even like React is much like this. React has massive bundle sizes, right? React is still sending a ton of JavaScript to manage the application and perform all the different functionality that it needs to. Um, and so, really, like you're just kind of off the jump, like you're done for if you have this massive file size. And so I have a very tiny bit of JavaScript. I actually just have it here. It doesn't really matter whether I send it as a separate file or just a plain script. Maybe I'll look into that in the future. But for now, I there's a reason for the code that this is actually more ergonomic. But this is the entire set of JavaScript that we have, and it's really small. Um, yeah. Very, very small. There's arguments I can make for how I can make this even smaller, um, but it's tiny. And the reason for that is because we just simply need the bundle size to be great, to be tiny, in order to have, um, in order to meet these SEO requirements, right? So yeah, so basically, then I had the challenge of just how do I integrate a landing page functionality with a Obelisk project. And I'm not going to name names or whatever, but there's an Obelisk project that I know that I believe that their landing page is actually done through Obelisk, and it's very SEO non-performant. And so that just, again, it just right off the bat shoots you in the foot because no one's going to find your site um, because of how bad your SEO is. So um, I got to work on this, and I thought, okay, well, here's the first thing I need to do is I need to go to my backend. I need to go to source, and I need to say, where is it? I need to have basically this. I need to have a backend route that is going to serve my landing page, right? And the reason for this is because the backend, this is kind of a detail of the Obelisk project, is that the front end is compiled by GHC.js, and the backend is compiled by GHC. Reflex works in both environments, as does really everything. Well, for the most part, everything. Everything that should work in both environments, right? Everything that should work on a client works in GHC.js. Everything that should work on in Haskell in general, of course, works in GHC. You'd also be surprised at the amount of stuff that you can run in the context of GHC.js. The only example I can think of that doesn't fit is HTTP client, because how are you going to do that on a browser? You have to use the XHR request on a browser, but you can use monads. You can use I imagine even effect systems if you really want to get into it in GHC.js. And of course, all the basic kind of prelude stuff you can use in GHC.js. Anyways, so the thinking with this is actually where the core problem lies. Is I need the backend to serve the landing page, and right, based on everything we have learned about SEO, the ideal is not how JavaScript people think about it. Right? We kind of like we want to send something that is as plain and stupid as possible. Right? We want to send something that is as plain and stupid as possible. So this is doing this actually, but the first version of this basically looked more like this. Looked like landing base. If it is requested, you know, um, read file my page .html. Right, this is just a string, and then I just say, I forget what it is in oh yeah, write text for a snap, which we are using here, and write text page, and that would send back a HTML document ultimately, which would be read by the browser. Now, here's the point that I'm trying to make: is this? It sounds. I mean, it's kind of a throwaway comment here, but this HTML serving is miles more efficient than Next.js or React or any of these other systems that you could use to build a landing page. Um, and I also there's a million other reasons we can talk about why React and Next.js can really send you for a loop. So, but yeah, we just the key point of this is that we want to be able to send HTML um, as dumbly as possible. So we want a system that is going to output HTML. We want a complex system, a system with the complexity that allows us to kind of work freely, right? But also at the end of the day, ends up being HTML. Further, when we are working with landing pages, we have kind of two cases. We have like your typical page, but then you also have like Markdown. People writing Markdown that are maybe non-technical. You want to have a blog on your page, and you want them to not have to figure out React in order to write a blog post. So we kind of need to facilitate these two things, and ultimately, even with Markdown, we are not serving Markdown, right? We convert Markdown to HTML, and then we serve it. Uh, and yeah, so there's another problem here. There's another motivating problem, which is I'll just show it here. So starting with the front end, we had this like these set of games that we did, and I built this system. Where's a good example? That's a non-example actually. Should be newer. So I had this system called Clash, right? And what is Clash? Let's go to the browser and check this out. I believe I have a local server running. I'm actually running this through Obelisk. So if you type obhoogle in your command or in your project, it will give you Hoogle loaded up with all of the different projects you're depending on, no matter what project they are, which is really cool, really helpful. And for example, I have my own projects here. So I have Clash. And this is the Clash the Clash library, which I still actually need to. I want to upload this to Hackage. There's a version up there which is very old. And it's basically all just one module. It's very very crappy, the version of that is uploaded. This is nice and all refactored and stuff. And I have built out a lot of different functionality because I hate typos. I do not want to have something like this. This is old code here. I don't want to have something like this where I have one typo, right? Or even like someone submits a pull request and they accidentally said like something like this. I hate that so much that all that's missing is a dash, and we have this kind of weird code, where maybe it's visibly broken, maybe it's not very like maybe it's gotten more subtle than that. But either way, we now have this like kind of janky, invalid value that is going to make maintaining this code a little bit more confusing. And so I built Clash, which just basically builds out this string, this Tailwind string. And the reason I use Tailwind, by the way, is because it's a lot. It just provides Tailwind's a great base on top of CSS, and I have the ability through Tailwind to customize to the level of CSS inline. So that's what I've done. And I had this problem because I built this beautiful beautiful Haskell Tailwind library, and I thought to myself, well, frig, like I don't want to write HTML and then have to like be back to writing, Tailwind like from scratch again, and that's just not very very neat. And so I thought, like, how can I build a system that allows me to continue to use the libraries that I'm building out, right? Even just from a matter of components, right? And this is what React people talk a lot about, is like being able to reuse components. Um, I think they're actually not as reusable as people say they are, because, well, I mean, of course you can reuse them, um, but you have to combine these components with other components. It very easily, a page can become a soup of components where you have JavaScript errors happening and you don't even know why they're happening. A case in point is, well, I guess I should talk about the particular project in mind, but there's a company that I worked with. Let's call them Metro Safe. Metro Safe is what I'm going to call them. And they had a React project that was just littered with bugs all over the place. And like, to my understanding, the point of why you use React is to avoid these bugs. Um, but it doesn't. It's not a very good stopper from you writing bugs in your application. So um, yeah. But we want to be able to reuse components, and there's a lot of components that I have on the front end, in the front end directory, that I was like, well, if I see a case where I want to reuse them, then I want to just be able to reuse them. So by definition of my problem, I want to keep everything in Haskell. And why I want to keep everything in Haskell is that allows me the most flexibility to build better systems and to reuse code. Right? If something is in HTML, even if that component comes up in that file 7 times, I have to like rewrite that HTML 7 times, right? Like this, this even this here. Like I would have in HTML, 6 different lines of code, so to speak. Not actually lines of code, but let's assume these are all one-liners of HTML. Then I have to write that 6 times. And so again, React does help with that, in that we can reuse that instead of having so much HTML. But the problem with reusability of React is that, can I take this component and place it in a new project? Right? If I am working for a new customer, just building landing pages even, right? A simpler case than other cases. If I want to reuse this component, I can't easily do that. Because there might be bugs in the JavaScript of that component, right? A component is really, it's a lot of things. It's the trifecta of HTML, CSS, and JavaScript. And so my theory is, and this is what I've never understood with web development, is, again, let's look at this JavaScript here. Oh, well, that's different. Okay. That is a small bug that I need to fix. I think that might have to do with a CDN issue. Um, I've done a lot of customization here, but again, ultimately, like, this is the entirety of the JavaScript that I need. So I don't know why I need an engine to handle this. Um, and so HTML and CSS are far more of the work, right? If I have, like, there's some JavaScript that applies to these, for example, right? These expand. So I have JavaScript to deal with that. But what, like, just more of the work, if I had to rebuild this function, sorry, if I had to rebuild this component, is in the CSS and the HTML. And so, like, it's easy to do the JavaScript. We might be scared of the JavaScript, but I think, that is something that we will learn in time, right? We might be brand new to coding, and a lot of people who are doing web development, it's kind of the first thing you do when you get into coding. For me, it was web scraping, and then it was web development, but uh, it's it's very early on, so you see a lot of web developers that are still learning how to do logic. But the but what I'm saying is the actual logic that you need to do is very very small. It's very tiny, right? The amount of code you're not going to have, you don't need to have thousands of lines of code to do JavaScript, for example, for a landing page. Yet these systems, um, actually tend to, and it's so bad because it also affects the SEO. And so, like, what I have said to myself is that I am just going to build a beautiful system to build HTML and CSS. And then I will gear it up with the I will reference it, right? I will have some system. And I haven't done this part yet. That's to come. But what I'm going to do is I'm going to basically say I'm going to have literally a Haskell system to say, uh, get me an object and do something with it, right? It's going to be a smart writer to basically build code like this. So I don't want to touch JavaScript even. I'd rather do Haskell, um, but I'd still rather touch vanilla JavaScript than deal with the overhead and annoying complexities of React that make more work than if I had just used vanilla JavaScript in the first place. Um, but yeah, so that's that, and so that's part of why I had Clash, is because I thought, well, if I just have these things as types, then this will make my life a lot easier. Let me show you an example here. Uh, color. Color is a very simple one, right? So this is an example use here. So I'm just setting the background color to black. And you might see at this point that I am using template Haskell. I mentioned that I was frustrated with typos in CSS and Tailwind, and you really should never be like, it's just kind of a architectural thing that you shouldn't be writing pure strings, right? That's just never a good thing. And um, so yeah, that's part of why I wanted to avoid it. But um, the other challenge is I could write something like I could write, in here, I could say background black, background white. And if I was to ask you, well, what happens? Is it going to be background white or background black? I guess you can see that it's white still. I wonder. Let me check something here. If I go like this. Oh, okay. So I guess this is something else. I don't even know what we're looking at here. Interesting. But this normally would work. Oh, you know what? There's no tailwind on this site. But if this, at least from my knowledge, but if I showed you this, right, in the code, we're not looking at this at all, and I just show you the code, do you know what that's going to do? You might know Tailwind very well, but and be able to say that, oh, it's going to be background black, because it's going to be the last item in the queue. The last item that it sees is going to be the class that applies. However, this is just pure, like, we could make no counter argument to this is bad code. This is horrible code if we see this anywhere. So we don't want that, right? We don't want to allow for that. And so the reason I'm using template Haskell to build something as simple as a Tailwind string, again, which seems so simple, is that I could be an idiot. There's no reason here. I could then try and say that the background color is white. And if I did that, I would get a complaint from the compiler saying, yo, you can't do that. Like, make up your mind, right? Like, people are so afraid of like compiler errors. It's really telling you like you want to fix this. Like you don't want that. Like trust me, bro, you don't want that. And uh, and I do not want that. And I will. There's no case ever where you want this. Um, but yeah. But and you can see these are just like normal Haskell types, right? If you're not familiar with enums in Haskell, then this is a great place to start because I can see that I have a number of options for what a color can be. I can see that it can inherit. They can pick the current, transparent. It can be black or white. And it can also be this color num. And what is this color num? It is just ultimately the values that we would see if we were to go and check out Tailwind, right? We can't do background red 401. We can do 400. We can do 300 up to 900. Um, and so we might as well encode that in our types. So I really again that's even another case I could screw up here, right? I could say background gray 910, let's say. And I'm thinking like, oh, that's you know, that makes sense to me. But and maybe even like my eye is kind of playing with me and I'm like, let's say like, the actual background color I set this to be is background, I'm making this up here, but eggshell white. And I go, oh yeah, no, that looks different to me. I lied to myself. I've visually tricked myself, and so it's nice that we have this kind of data type to say that makes no sense what you just told me. Um, yeah. So um, so yeah, that's an example of the Clash library that I built up. And so what's cool about this, and I think this is a generic lesson for type systems, right? For building your own type system, for modeling your domain through types, is that I kind of noticed, huh? Like I applied Clash a bunch of times, right? And maybe, hopefully I can find a good example here. Okay, I'll use this, and I would say something like um. Let me copy this here. Oh, well, actually, sorry. There's two examples here I'm noticing. One, I would notice that like, I kept saying basically that I want the position to be centered. So I want to justify center horizontally, and I want to align center, so vertically. So this is directly center, which cool. This is kind of a cool thing. Apparently, this is challenging. I'm just kidding. I know it's challenging to do with normal CSS to center a div, but this actually does it very, very easily. This is everything you need to center a div right there, and it will always work. And and that's kind of more because of the internal mechanics. Now, but to be clear, there's not that many mechanics. This is a very simple system. Um, and anyways, so I noticed that like, a very simple one. I kept saying that, and so I would just say centered, right? Position equals centered. I also kind of made it more ergonomic, and I said pause equals centered, um, etc. And that's very obvious that I could do that. But the key thing is, I kept noticing that I would do something more like this. I kept saying, okay, I want this to be size 8, padding on the top or the bottom. Let's change this to so I had this as padding X. I'm going to now change it to padding top, and that is just a function in Tailwind, or in my Clash library, that just sets it to being having a top padding of whatever I set here. And yeah, I won't dive into like how does Clash work. Maybe I'll do that in another video. But ultimately, I noticed by using these types that I was doing the same thing over and over again. And so I would create helper functions uh, that I would just kind of reuse my code. So not only like were my components starting to become like very reusable. Again, I could use this video example anywhere with the guarantee that it works. Right? It's just HTML and CSS. There's nothing complicated about it. Right? I can use this anywhere. I can use this. Funny enough, this is because of Reflex. I can use this in my I can use this in my application, right? My front end application, and I can use this in my static landing page. So basically, it is extremely reusable. Even across different compilers, it stays reusable. So I don't know how you can make it something more reusable than that, and it's powerful. But I actually just to actually show, I have this other library called Reflex Clash, and right, I would. This is kind of like just helper functions here to define certain elements, and um, right. For example, like this image source set. This is actually a way to build for optimized, um, optimizing your images for mobile um, as well as for just desktop. So because like there's a way in HTML. I think this is another key point. HTML does a lot more than we realize. Like HTML, you can um, use, I forget what it's called, but there's a very particular tag that allows you to pass a set of images, and based on the screen size, it will pick it responsively. So, but I noticed that there's a lot of commonality I had for my layouts, right? So I would do something very similar to this. And so what does this do? Um, this basically builds, well, I have a row with a vertical padding of 10. I create a grid with 12 columns. And then responsively, right, responsive to the screen size, I am going to make this so that on mobile, it's going to be 12. It's going to take up the full 12 steps. It's going to take up the full 12 steps on small size. And then everything up from there is going to be 3 of the units of that grid. Right, so it's going to be like, so I'm going to see, hey, hello, howdy, just like that. And so, yeah, I noticed I was reusing this over and over again, and it was very easy because I was using typed Haskell to just say, I can separate that. I didn't have to like go through tons of work to figure out how to do it with components, which is it feels like something that should be straightforward and obvious, but it's not actually usually in practice. It just becomes code bloat, and well, it becomes code bloat that you can't really easily solve for. So yeah, same. This is kind of more fun. I have like a bunch of places where like I'm just doing kind of very plain old paragraphs, and I was just like, I want a paragraphs function to help with that, and I have this like kind of size to say the spacing between the paragraphs, and so just again, I have a lot of functions like that, and anytime I kind of realize I keep doing this same pattern, I just easily upstream it to this package, and I can just this is basically you can think of this as a easy way to build components, right? To build custom components. And so anyways, this is hopefully demonstrating like why I was like, crap, like I am motivated to retain the power that I have built up in Haskell because right, I've used it for the application, and now I want to use it for uh, for my backend. And so let's actually get into that. So how are we doing this? So we have um, again we have our static build, which is just again kind of like originally this was actually doing our markdown, like I was saying, but it's also doing our CSS, which we need to do. And that actually kind of created another challenge. Is that I can't so the way that Tailwind works, it's going to scan your files for the classes. So if it for example sees this code, right? If it can look at Haskell code too, right? It's able to look at Haskell code, but if it sees this code, it doesn't know what to do with it. It doesn't know that this is um, padding x8, and so it won't include that class definition in the compiled Tailwind. And so I have another problem in that I still need to output output Tailwind. I still need to output. Oh, what the heck? I still need to output Tailwind, and so I am able to do that because if we look at this static directory here, I have HTML output, and this is all of the HTML that we are building. And what's interesting is that if you look at this, these are also originally Markdown documents that we have created and are now as HTML, where we can, if we really wanted to, we can use Tailwind on those as well. And so we have a full build process that has compiled Tailwind, which is very important again for SEO, and we have our HTML that we can just easily ship to the person requesting it. And so I'll just jump here into my landing page. And so this is the core of our landing page. And this is in JavaScript. Or sorry, this is JavaScript. No, this is in Haskell. And this is effectively my router for the application. It's very straightforward. Yeah, it's just simply very straightforward. And I think it's kind of self-evident about kind of like what am I doing here, partially. So I'm you see this kind of serve function, right? I'm serving to the user some file path. So what's cool is based on the route that I have, I am serving some file path, which is just kind of, this is basically just like any other sort of static site, right? Just if there's a Snap even has handlers for just serve static directory, which is very straightforward. I wanted to go a little bit of a step further, and because there's a problem I realized early on, which is the build process, and I'll show it with Markdown actually. Landing pages, Markdown. If I go to chapter 0, I should have this open somewhere. Localhost 8020. I believe it was landing blog main. Yes. No. Well, okay. Let me go to the correct one then. And I wanted so. Imagine this: like you're a writer, and you want to see how this looks from Markdown. and I just say, oh, I actually wanted, I typed this wrong. Where I actually want it to be tutorials or something. Um, that was so fast. Oh my gosh, did I miss that? There we go. And that is immediate, right? There's immediate feedback on how does this look, um, as someone who is developing the page, right? Because it would be awful if, like, imagine I kept changing the CSS and then I have to wait for it to rebuild, and there's like, it would suck. And that problem came into fruition because um, every time that I am rebuilding, um, every time I'm rebuilding, I'm actually doing another thing, which I'm rebuilding a Nix derivation, which gets complex. I am rebuilding a Nix derivation. So why? Actually, I should explain that. But uh, but yeah, with the keynote that I have figured out a way around this. And so why am I building a Nix derivation? Well, we have to go to my other package, which is still unreleased. I just have it under Thunks. This is a GitHub. This is ultimately just a GitHub repository that I'm building into my application. Um, and where am I going here? Yes, I have this kind of system here, which is really entirely contained um, right here. There's a lot to look at, but basically what this is doing, and I don't know why I needed to show this on second hand, because there's more to think about than necessary. But we're basically just, actually, this is kind of more informative. We are finding a way to convert between the route and the file path. So, for example, if our route is set up at landing slash example, then we are going to want to write a static HTML file, a generated static HTML file, to slash landing slash HTML of some base directory. Again, that's why the previous thing that I showed was a little bit more complex, is because I have allowed for a lot of flexibility in where do we put that directory. But there's also kind of a standard way in which I've done it, at least for my stuff. And so yeah, all we were trying to do is we are trying to write a file. And we have kind of two cases. Basically, we write the file and we are in development. Right, we are locally running this if we can write the file, or when we are deploying, because of the Nix environment that we deploy in, we actually don't, and this is actually this is nothing nothing beyond the normal Obelisk, is that we are building, and we don't necessarily have access to that directory because Nix is kind of you can think of it as a bit of a virtual build system, and there's actually just no directory at that time. And so, like, I originally had well, let me just say this. I have basically set this up so that if we can write the file, just give me back that file that you just wrote. And if you were unable to write the file, just give me back that file that you just wrote. And that sounds funny, but there's going to be two different cases. We're either going to see that the file path is at static site slash HTML, or we're going to see that's at like Nix. Nix. It's ultimately in Nix store. The ultimately in Nix store, which is handled through Obelisk. So we're still going to see static site slash, and then we have that massive hash, right? HTML, and that's what we saw in production. Locally, we do not see that, I think I can actually prove this. Is that the same? Huh. Ah, never mind. Interesting. Okay, well, but okay, maybe I'm forgetting what the details are, but ultimately I have factored out the details so that we can basically immediately get the file if it's local development, or we get the Nix, the way to refer to it through Nix ultimately. Um, and this is again like the core reason for this is that we want to tap into Obelisk's guarantees. So I showed before that we can use this static images, right? We can just say static image um, something.png. I would also like to be able to say uh, static HTML, and I have base.html, and this is my landing page, the core landing page. I want to be able to get that um, and work with that, and I want to have the compile time guarantee that in production I'm going to be able to get that file. And so again, this is all set up through Obelisk already, and I can just tap into it. Um, and so the way that I do that is I can basically just use um, this kind of static file path. Right, the static file path is ultimately it's actually a function. It's directly a copy of the name of the function in Obelisk. Obelisk. I forget the name of the library specifically, but Obelisk Asset Serve or Obelisk Asset is what I'm going to call it, and it just gives us that guarantee. So, but yeah, if we were able to write that file instead, we just get that file path, and now we can immediately get it back. And so, like, that's why we were able to see when I did this locally that I could just easily and quickly change tutorial to tutorials, um, and it would work properly. Now, so that's the core of what we're doing. The Lamarckian's core job is to basically be a relationship between the route and where can we find that file. And that allows us the ability to have sort of complex logic on how we write this. So let me just find the actual example. Um, we have this Markdown route. I'm gonna look at instead the main landing page. Okay, so get main page compiled. This is from my implementation file, and get main page compiled is ultimately this, right? It basically um, representing that config that I talked about with how do we tell A if we're in production or not, and B um, where to write that file. So this is all to support a widget, right? A widget, and this type right here is actually from Reflex DOM. And we now have the ability to well, I actually need to go back to the marking for this. I'm now realizing. And all we do is we just simply create HTML doc. So we have a way. This is basically just rendering. If you're familiar with Reflex, the function we are using here is basically just render static. And actually, you can see that I have two other functions here that come up, um, which I haven't gotten into yet. But yeah, we're using ultimately render static. So take this widget that we've created and just render it as kind of plain HTML. So that's already done for us, and we are just basically wiring that in so that again we can go from Haskell to HTML in a very clean way, in a very clean, optimized way. And so like, there's one key pattern is that like at um, in development we have the ability we prioritize quick builds so that we have immediate feedback, right? I would be willing to bet that this actually compares for speed to what is it the new Vite framework or something. I think it's Vite, which I think is from the creator of Vue. Anyways, it's touted as very fast builds. This is probably faster. I haven't cared to benchmark it yet, but I'm willing to bet that it's faster, just for the simplicity of what we're actually doing here. Um, and oh, now, so what does like one of these pages actually look like? So go to our HTML, and let's look at our index. And so this is again another reason why I wanted to use Haskell is because now I can really reuse a lot of my code. Um, we have this common shell where we realize we kind of want like basically the same HTML head, but with a little bit of configurability, and we want I forget what this is. Oh yeah, well we can actually just pass whatever the head is, but um, that we do some of what I was saying there, anyways, in which we basically have like a head builder with the ability to configure it, and then we just have a number of vertical sections, right? That we just stack on top of each other, because we realize that that pattern exists. Um, and yeah, so it's this is very straightforward. Like this is just a number of elements, and what I'll say is we're not actually using Clash here yet, which sounds funny because I'm talking about how why I did this was to use Clash. Um, but granted, I think it's still amazing with the fact that um, of how we can use it. Now, um, that's kind of secondary and just not a key thing we need to do immediately yet. But if I was to now come in and I want to change something here, probably the first next step I would do is I would use Clash. But again, ultimately, I just have the full power of Haskell to build what is basically just a simple, HTML script. I also did something fun here with more template Haskell. Oh, it's in scripts. I have this script I make where I've used a this package called iString, where all it does is allow for interpolating a string and having a massive chunk of it, because of quasi-coders. Um, and so I use this to add in variables here, right? So we rotate. We kind of have a carousel of. I'll just show this. Easier to show. We kind of have a carousel of things here, and we have this image, which is loading a little bit slow at the moment, but we want to make sure again that image is the correct image, and so we can use that by making sure we get the correct image through more template Haskell, and then we can use even more template Haskell to go and interpolate the string, so that the JavaScript that we're writing, and again, there's so many ideas I have with this, and I think this is kind of more of my focus on the next piece that I want to build, is we can write, we can have a very simple set of JavaScript that is a little bit safe, is much safer than JavaScript. So kind of think of it as like a micro GHCJS is what I am going to work on just next. I have another project called LazyJS, which is a work in progress. That's more for fun to see if I can um, interpret JavaScript in a lazy manner. Of course, I know that there's notes to be said there, but yeah. And so I have all of that capability, um, and I'll just show you even here too that I can just do Markdown, um, and yeah, I have another quasi-quoter here, which I kind of named it out of humor. The package mmark is made by a guy named um, Mark with a K at the end, I believe. Mark, like last name K, something. And so basically, this is just a quasi quoter that compiles whatever is in here, I should say, uh, using first a um, the string interpolator, and then also using um, just literally rendering it to Markdown. And if we get a error with our Markdown, then we get a compile time error. And I think I can actually show this. What's an easy way I can do this? What if I do this? Does that give me an error? Yep. So that gave me an error. That gave me a Markdown error at compile time, which is awesome. Um, and I can just, yeah, I can sleep safely knowing that I'm not going to have some ugly, blog because I accidentally removed one character. Um, so yeah, that's I think that's pretty cool. I use the I string here to integrate Obelisk, um, because I want to be able to have a safe link as well. I don't want to have a link that's become outdated, and so I have this function local link where basically, where is this? Blanking on this. Oh, it's in utils. Yes, it is local. There we go. All this does is just simply render a link properly um, to somewhere in the document. Um, and we also have a another Markdown link where we can call to another section of the blog. Oh yeah, okay, because I have the error. Does that work now? Perfect. Okay, and I can go to introduction. That works properly. I can go to recap exercises. I can go to the previous chapter, and I have kind of safe routing, right? So I have this kind of the best of both worlds. I have safety, but I also have the freedom to just write in Markdown, um, which is pretty cool. And we use the mmark extensions to also be able to write Haskell and get syntax highlighting. Um, we really enjoyed using it for that reason. And yeah, it's pretty awesome. So that's really all there is to say. Um, and it just ends up being something that we can very easily manage. And I think this is kind of the last cool thing is I wanted to test something. This is I think a challenge of GHCJS is what I'll say is where it originates, um, and because I'm using so much template Haskell, is it takes a while to build our front end because we are using a lot of template Haskell, and I'm for that. I'd rather have slow builds that take some time, as long as the build is correct. So that's my opinion. But here I said I don't like if we just add a random blog. I don't want to spend 3 hours to build. Um, right? I don't want any. I don't want to have to change. I don't want any change in this landing page um, to cause my front end to rebuild. Um, yeah, and so why is that a problem? Is because right this here is originally from common with common route. Um, yeah. So if I rebuild common and common is a dependency of front end, then I have to rebuild front end, and therefore it is going to take a fair bit of time. However, I just wanted to have kind of the ability to avoid that, and so I tested this. I thought if I just do feature hiring, because it's a string, right? It's a random arbitrary string. Uh, like, can I do this? And will this work or whatever? And it just magically kind of worked because um, I can go and I can change this. So this is the route. I'm gonna just call this X, and I'm gonna say random file path. Okay. Now, if I go, I look at static site. Um, I have some old artifacts that I need to clean up in here, but if I go and I look at blog, yes, post, and I have random file path.html, and this is my compiled Markdown here. So I think that's really cool. Um, right, and I'll leave it off with just like how does this all tie together? Is that um, we choose where to write this generated HTML, and then because this this directory is itself a derivation, this is going to then be given as input to this, which is going to go and generate the Nix derivation of my static site, and that's the Nix derivation where I can get a compile time guarantee that yes, I have this thing generated, and I'm also gonna for sure have it in production. Um, so just tapping into what Obelisk has done. And so I actually, yeah, I guess I don't even need this here, but that is what I have done. That's what I've been up to. There's a lot of work that went into that between the WebSockets and um, the WebSockets. A lot of changes to our database. There's even more I haven't talked about with using Beam Auto Migrate that I'd love to talk about. But also talking about the static landing page stuff. So thank you so much for listening along.